In this video, we will discuss the applications of the first and second derivatives with respect to the object moving in a straight line. The object can be moving in a straight line in both vertical, horizontal directions. We have already discussed a scenario of horizontal direction motion. In this case, we will be taking a vertical direction motion example. Let's read the question first. In this example, a ball is thrown up and its motion can be described by height equal to negative 4.9 t squared plus 6t plus 2. H is measured in meters and t is measured in seconds. We are supposed to determine the initial velocity. Now from the previous videos, we already know that the derivative of distance is velocity. In this case, distance is represented with height because we are dealing with a vertical motion. So derivative of height is going to be equal to velocity. They want us to find out initial velocity, and initial velocity means velocity at time t equal to 0. All we have to do is first find out what is the velocity equation. So in order to find out velocity equation, we will just do the derivative of our height equation and we'll take the derivative of it. As now we already know the derivative rules, we just apply the rule and this gives us the velocity equation. This is our general velocity equation with respect to time t, but we are supposed to find out the velocity when time is 0. So all we have to do is just sub in time as 0, and the answer that we get is 6 meters per second. We have already discussed in the previous video that unit of velocity is meters per second. This is the next part of the question. When does the ball reach its maximum height? Whenever the question wants you to find out when, that means they want you to find out time. So they're asking you for time when ball is at its maximum height. Do we know the maximum height? No. Since we don't know maximum height, we have to remember that at maximum height, velocity of the ball becomes 0. And why do we see such a scenario is because when we are going up, there is a point after which the ball is going to then start coming down. That means at this point, the ball has reached its maximum height. And what is the reason the ball is not going up anymore and it is start coming down is that its upward velocity is 0. So it has lost all the velocity to go up. That's why it has now started falling down. So when it falls down, it does not need any velocity because it is going to fall down under gravity. Coming back to the question, now we know at maximum height Vt is 0, so all we have to do is just put Vt equal to 0. From the previous part, we see that our Vt is negative 9.8 t plus 6. That's what we will put here, negative 9.8 t plus 6 equal to 0. And then all we have to do is just solve for our time. So we would isolate t, and with this we would get t is equal to negative 6 divided by negative 9.8, which is equal to 0.612 seconds. Here we can conclude that ball reaches its maximum height at time equal to 0.612 seconds. Next part of the question wants us to find out when does the ball hit the ground. Now when ball hits the ground, the height of the ball becomes 0. So all we have to do is just put the height equation, which is negative 4.9 t squared plus 6t plus 2 equal to 0, and solve for t. Now to solve for t, we have either factoring method or formula method because this is a quadratic equation. So since factoring is not possible, we will be doing quadratic formula, and quadratic formula is negative b plus minus root b square minus 4ac over 2a, which is going to give us this. When we put this on the calculator, we get negative 6 plus minus square root of 75.2 over negative 9.8. This gives us negative 6 plus minus 8.7 over negative 9.8. We will get two answers for this. One is negative 8 plus 8.7 over negative 9.8, which is going to be equal to negative 0.27. Another answer is going to be negative 6 minus 8.7 divided by minus 9.8, which is equal to positive 1.5. Now going back to the question, we see we are looking for when. When means time. When ball hits the ground, so when height is 0, what is the time? Since time cannot be negative, we'll rule out this option, and then this is the only one option left, and then from here we conclude that time is 1.5 seconds when ball hits the ground, and that is when height is. This is our final answer. Next part of the question, the next part of question wants us to find out the velocity of the ball when it hits the ground. Hitting the ground means height is 0, and from here we have also found out that it hits the ground at time equal to 1.5 seconds. That was our previous answer. So when we complete part D, the question wants us to find out velocity, and we know velocity equation is negative 9.8 t plus 6. That was from part A. So all we have to find out the velocity when time is 1.5 seconds. We sub in time as 1.5 seconds, and then we put it on the calculator, and the answer that we get is 20.7 meters per second. Next we move on to part E. Part E says, what is the acceleration of the ball on the way up and on the way down? So for that we need first the acceleration. We all know that acceleration is nothing but the derivative of velocity. Our velocity equation is negative 9.8 t plus 6. We find the derivative of this, and we get negative 9.8. This is our acceleration. Unit for acceleration from the previous example is meters per second square. From part B, we found out that the ball is going up from 0 to 0.612 seconds. This is the time when the ball is going up, and then 0.612 seconds to 1.5 seconds, because 1.5 seconds it hits back the ground. The ball's motion is going down. Coming back to part E, we see that the acceleration is constant. It does not depend upon any time. So it does not matter if the ball is going up or ball is going down. We just have one acceleration value, and that acceleration is negative 9.8 meters squared. Let's go to part F of the question. Part F wants us to find out the direction of the object at 1 second. In one of the previous videos, I described about direction of the object and the way to determine the direction. From there, we will recall that direction is described on the basis of the first derivative of your distance, which is velocity. So if velocity is positive, direction is going to be right, or in this case, up, or we can say direction is positive. Similarly, if velocity is negative, we would say direction is left. If it's a vertical motion, then we can say down. Or in simple terms, we can say it's a negative direction. Now in this particular case, all we have to do is just find out the velocity at 1 second, because they want us to find out the direction at 1 second. Or in simple terms, they want us to find out the velocity at 1 second. Our velocity equation was negative 9.8. In place of t, I'm going to put in 1. And when I put it on the calculator, I see the result that I get is negative 9.8 meters per second. Velocity at 1 second is negative. We can conclude that the object is going down. Next part of the question wants us to find the velocity of the ball if it is caught 1 meter above the ground. When they say 1 meter above the ground, that means you're given the height of the ball is 1 meter. We have to find out what is the velocity of the ball when height is 1 meter. Now we see that height and velocity have one variable in common, and that is t variable. So all we can do is just find out time from the height equation and sub that time in velocity equation. In order to find out time when height is 1 meters, we'll put in the height equation equal to 1, and we would solve for t. In order to solve for t, we'll move this over, and we'll be left with negative 4.9t squared plus 6t plus 2 minus 1. When we simplify the equation, we get negative 4.9t squared plus 6t plus 1. Now again your equation, which is a quadratic equation, is equal to 0. So we have to solve for time. We will be using quadratic formula. Our quadratic formula is this. When you sub in all the values of the quadratic formula variables, you'll be able to get negative 6 plus minus 7.45 over negative 9.8. That would give us these two answers, negative 0.14 seconds, and the other one is positive 1.37 seconds. As time cannot be negative, we can rule out this negative option. So from here we get to know that at 1.37 seconds, height of the ball is 1 meter. Now this is something that's common for both height and velocity, and we have to find out the velocity at 1.37 seconds. So all we would have to do is just sub in 1.37 in the velocity equation and see what we get. And the answer is negative 6.33 meters per second.